Now let's look at this table to understand the electrovalency. What is electrovalency? Electrovalency is nothing but number of electrons that are lost or gained in order to form a stable electronic configuration. Now as you can see in the table, you have group 1, you have group 2. What are the elements that are in group 1? That is your Li, lithium, sodium, potassium, rubidium and cesium. Since this is a group 1 element, it is 1 electrovalency, correct? So that means what? The electronic configuration or the valence electron in the group 1 element is 1, and that 1 electron can be donated to form a cation like sodium plus. Similarly, if you look at group 2, you have beryllium, magnesium, calcium, strontium and barium. So since it is a group 2, now the electrovalency will be what? Electrovalency will be 2, because again if you take example of magnesium, the magnesium can donate 2 electron to form Mg2 plus, and hence the electrovalency is 2 of group 2. Similarly, if you look at group 13 now, what are the elements that are present in group 13? That is your boron, aluminium. If you take example of boron, what is atomic number of boron? Atomic number of boron is 5. So the electronic configuration of boron is what? 2 and 3. Now this 3 electron can be donated in order to form a stable electronic configuration of noble gases. So we can donate this 3 electrons from group 13. So the electrovalency of group 13 is 3. Similarly, if you look at group 15, group 16, group 17, in group 15, you have nitrogen, phosphorus, arsenic, antimony and bismuth. Similarly, your group 15 can also donate 3 electrons in order to achieve stable electronic configuration. Hence, the electrovalency of group 15 is also 3. Now let's talk about group 16, which consists of oxygen, sulfur, selenium and tellurium. So your group 16, let's take example of oxygen, atomic number 8. So what will be electronic configuration? 2 and 6. So now this can accept 2 electrons, correct? Not donate, because oxygen is electronegative in nature. So it will accept 2 electrons and will form a stable octet. And this is how oxygen has electrovalency of 2, because it accepts 2 electron and not donate. Same is the case with group 17. Group 17 is nothing but your halogen. Halogen means what? Fluorine, chlorine, bromine and iodine. These are your group 17 elements. So if we take example of fluorine, electronic configuration 2 and 7. So it requires 1 electron in order to achieve stable electronic configuration. So when we talk about group 17, the electrovalency now will be 1. Why? Because your group 17 requires only 1 electron in order to achieve stable electronic configuration. Now let's move ahead. I hope this table is clear to you now. It is very important. Please mark this as important. So in exam, the question can come, they can give you the element and they will ask you what is the electrovalency of this element. So depending upon the group in which they are, you have to just give them the electrovalency. Simple. Now let's move ahead. So now that we have understood about electropositivity and electronegativity, now you can say that more is the difference between the group number of the atom of 2 elements participating in ionic bond, more is the strength of the bond, correct? If there is a bond formation between group 1 elements like your sodium and group 17 elements like your fluorine, group 1 extremely electropositive in nature, correct? And group 17 is electronegative in nature. So the difference between the group if you see, group 1 is on the extreme left hand side of the periodic table and group 17 is on the extreme right side of the periodic table. So the difference between the group is large and hence the bond formation will be stronger, because one is on extreme left hand side which is very much electropositive, and one is on extreme other end which is highly electronegative. Thus we can say more is the difference between group number, more is the strength of the bond. Correct. Now let's move ahead. Now see the order of ionic character in fluorides now. So when we talk about fluoride, lithium fluoride, sodium fluoride, potassium fluoride, you have rubidium fluoride and then cesium fluoride. So if you see the order is increasing. Why? Because now let's take the consideration of size. If the size of your electropositive element or electropositive atom is increasing, then the bond strength will also increase because the ionic character is increasing. Remember this. Hence, in case of fluorine or in case of fluoride, the electropositive character of lithium, sodium, potassium, rubidium, cesium is increasing. Hence, the strength will also increase. Similarly, if we look at the halogen and sodium, same is the case. Now, fluorine is extremely electronegative. Hence, the ionic character of sodium and fluorine will be high. So, the bond strength will be high. So, as you go down the group in group 17, the electronegativity decreases. Correct? So, the bond strength will also decrease with the same cation. So if we consider chlorine, fluorine, bromine and iodine with sodium, then the bond strength will be sodium fluoride will be higher, then comes sodium chloride, then comes sodium bromide, and then comes your sodium iodide, which is at the bottom of group 17.